data at this time. However, you need to manage the study and the length of the file. Then, for example, when I read the data from the mail, okay, mail which is located in the last block, how many blocks do you need to read? First, you need to read the block, directory block, okay, directory 1. Then, using the directory going to the 19, 1, 2, 3, 4, 5, 6. You need to read until you find your data block. Okay, that is the overhead of the contiguous allocation. It always start from the beginning block, next until you find the data. To address that problem, definitely you can see it's a fragmentation issue. Even though we have the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 free block, we cannot create a 13 block size of file. It's a fragmentation issue. To address that problem, so some of the operating system use extend. Extend used a lot actually, especially in the database, because I'm teaching database also. So extend means instead of block by block, why don't we make the small number of group of the block, like the 4. So we can define the, in this case, 0 to 3 is one extend. They are always working together. Even though 5 need one block, we can allocate one extend. Then another extend is a 4 through 7. Another extend 8 through 11. So always is a 4 block is the kind of block. It's called the extend. So extend is slightly larger, the size of the data structure. It should not be very large. It will have the fragmentation, internal fragmentation, the issue. So extend makes the system reasonably reduce the problem of the fragmentation. As long as we can find the extended size, it's okay. This approach is used a lot in the database system, extend. Okay. The next allocation method is the linked list. I confused with the linked list. Linked list is like this one. In the directory, we have only the start and end. Start going to 9, and this one has the next to this one, next this one, next to this one, next to this one. -1 means it's a null. Null means it's end. Then it's a similar, not similar because there's no fragmentation issue. As long as we have the free block, we can use it. Problem? We need to use the pointer part of the block at the 4 byte as a pointing address to the next one. So slightly reduce the utilization, but it's okay. But this time also we need to access 9, going to 9, next to this one, until we find the data. Okay, so that, oh, by the way, what if here, contiguous allocation, if we know the offset, do we need to access from the beginning? No, we can calculate, actually. Okay? If we know the offset of the data, like we know the data, the 1000 byte. 1000 byte means the second, the block. So we can calculate the second block is 50. We can directly go to the data and read it. That is a contiguous. But obviously, the linked allocation, we need to read always from the beginning. Otherwise, we don't know where the next one is, the middle one is located. That is a contiguous linked allocation. The problem, less utilization also is displacement in the block, always R plus 1. FAT, file allocation table, is actually idea of FAT. Depending on the size of the block, it can be FAT, FAT32, and so on. So FAT, the Microsoft file system used these approaches. So this is a FAT. You can see that only it has the directory structure has a starting block going to this one, and this one is the end of the file. The next approach for the allocation is index. Index means like the one block will be used for indexing, where the data block is located. So directory structure has the pointer of the index, and index has the location of that. Then we can read. For example, when you read the data of the 25, 1, 2, 25, 3, always 3. However, you need to manage the index. Also, if you lose the index block, you will lose the file. So that is the point of failure. So that is the index allocation. Okay? But if we have this huge file, we can make the index of index. If we have the too many index, we can create the index of index. Okay? Then finally, if we combine such a single level, double level, triple level, and what the direct block, combining all of this will be inode. Then at this time, if the file is frequently accessed, we can allocate the file here. Okay, director. But if not frequently accessed, we can use the triple indirect. Total, we can calculate the size of the block. In case of 32-bit, it will be 4 GB. That is the reason long time ago, when we are using 32-bit processor, the file system size is limited to the 4 GB. 64-bit, almost no limitation. But in case of 32-bit, but my final exam question was, why is a 4 GB?
Maximum addressable size.
It's based on you need to calculate how many. Okay, then it will be 4 GB. So if you are interested, look up the textbook and the Wikipedia. It explains the detail. I'm not sure Wikipedia shows this one, but my old textbook when I was a student is covered almost the chapter. So, but I don't think it's practical nowadays because we are using 64-bit is still virtually unlimitation. Okay, so we will talk about the performance the next class. Then the last chapter 13 will be very short, but the next class we will finish the chapter 12. Then we'll have the quiz. Okay, any question? Those who answer, please come front. I will record for your extra point.